Excellent. In this lesson, we will explore the interaction between the chaining technique and writing assignment statements in Python with two pandas methods, sort values and sort index. It might look like we've loaded up too many eggs in one basket, but that's what the combination of analytics and programming could require at its most interesting. So, let's just start. First things first, please execute this cell to import and store the information from the location CSV file into a series object we'll call location data. To create a series relevant for this study, apply the sort values method to the location data object and set the ascending parameter equal to false. This operation will sort the values of location data in descending order. Next, store this output into a new variable called location data SV, where the acronym at the end stands for sorted values. Implementing the head method here proves that we've worked correctly. Until the end of this lesson, assume location data SV as the example object on which we'll apply the manipulation in focus. All right. In that case, let's refer to the index attribute to see how numerically unordered the index values of our example object are. So, if our task were to reorganize the index values of location data SV by determining the sorting as ascending, for instance, we can chain the default version of the sort values method to this expression. As we run the cell now, we do obtain all index values in ascending order starting from 0 and ending at 1042. Now, there are two important consequences to note here. First, sort values didn't override the contents of location data SV, and the head method in this line of code proves it. Second, the technique of chaining the sort values method to the index attribute is only useful if you need to obtain the sorted index structure as a separate entity for some reason. To better illustrate the idea, we can override the obtained output as the series index, and then display its contents to see that only the index values have been rearranged in ascending order. You can scroll up to compare this outcome to the one obtained earlier to see that the order of the values hasn't changed. To continue our journey, let's recreate the location data SV file from the location data series in a well-known way. As a reminder, you can observe that the values have been sorted in descending order at the expense of the scrambled index values, so to speak. Now, instead of referring to the index attribute and the sort values method, you must know there is a method that will directly reorganize all values of the SV series according to its index. Very intuitively, it's called sort index. Sort index is a complementary method to sort values, and to prove it works in much the same way, we can apply it to location data SV. The output is exactly as expected. All rows have been sorted according to the initial series index. Great! Likewise, sort index creates a temporary copy of the object's data it's been applied to and displays the output of its manipulation. In other words, it doesn't affect the state of the initial data set. See? To implement the sorting, we can use the assignment statement you see here. We can also add ascending equals true in the parentheses at the end to explicitly indicate the order of sorting. Now, we've ordered the data in our series according to its index, which, by the way, is exactly how we stored the original location CSV information into the location data series at the beginning of the lecture. Remember? Lovely. I encourage you to do the exercises we've attached to this lecture and rewatch parts of it to solidify your understanding of the important concept of sorting series according to its values or index. Once you've done that, I'm sure you know that we'll be waiting for you in our next video. See you there.